Hey, welcome back. We're going to talk about a few other ways to organize your data. We did histograms, frequency distributions last time. And so today we're going to talk about three other methods. The first is a stem and leaf plot. The way that stem and leaf plots work is you're going to take each data number and you're going to draw a line right after the ones column. So this is a ones column right here. This 2, that's the ones, this is the tens, and you're going to draw a line right after the ones or right before the one, depending on which way you're looking at it, like that. And you're going to split up the numbers that way. A stem and leaf plot has a line down the middle, and everything on the right of the line, the ones column goes on the right, everything else goes on the left. So for this data, I would draw a line vertically, and I'm going to put all of the values that I see on the left-hand side. Now, what we do for stem and leaf, though, is we don't write 1 multiple times. We write it once, and then all of the things in the tens category go after that. So, for example, I'm going to write a 1 here, and then I'm going to put, for this data value, I'm going to put a 2 here. That's my 12. Here's another data value of 12, so I'm going to put another 2. So in essence, that 1 on the left is applying to all the numbers that I'm writing on the right. Then I've got another 12, so I put another 2. I've got a 17, so I put a 7. 18, so I put 2 8s. 19, so I put 2 9s. So the way I read that as somebody who comes to look at the data off the stem and leaf plot is I go 12, 12, 12, 17, like that. That 1 is applying to all of the numbers after it. Then I get onto my 20s in my data set here. Whoa, that was the wrong one. There we go, my 20s. So I'm going to put a 2 right here. Now 20 has a 0 afterwards, so it's a 0. Then I've got another 20, so that I've got another 0. 21, 23, 27, 27. Okay. Then I'm on to my 30s. So I put a 3 here, 31, 32, 32, 33. Then I've got the next thing that should come is 40s, right? After 30s is 40s. I don't have any 40s, but I still have to write a 4. In a stem and leaf plot, you have to hold each of your spots. So even if there aren't any data values, and then I jump to my 50s. I have 50 and 54. Now in that blank spot of the 4, I don't put a 0. If you put a 0 there, that means 40 is a data point, and it's not. So you just leave it blank. Then 50, 54, and then my last one is 60. And that's your stem and leaf plot. Okay. Now, what if you have triple digit numbers? How's this look? So say, I'll just write a smaller data set. Like say I've got 100, 101, 103, 110, and 115. Say this is my data set. You still draw the line to be right before the ones column. So these numbers are dividing like this, here, 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 and here. So you're always having single digits on the right. The left can be as many digits as you want. So on the left, I'm going to write 10, and then I'm going to write 11. So here's what that stem and leaf looks like. 10, 11. So I've got 100, 101, 103, and then 110, 115. And that's my stem and leaf plot. Okay. And again, if there's a missing value, you have to include that in the stem and leaf, but then just skip it and move to the next one. So that's how stem and leaves work. The advantage is very similar to a histogram. You can see where the bulk of the data is very easily. You can say, oh yeah, obviously most of my data is here. And that's an advantage. So you can see where the trends are in your data. The disadvantage of these, obviously, if you have 100 data points, this is quite cumbersome. So something like a histogram can handle large quantities of data a bit better than these where we're listing out all data points. So pros and cons of all of them. The next type of graph that we're looking at is called a dot plot. So I'm going to write out just a set of data, kind of a smaller one for us, and I'm writing it in order. By the way, if your data set's not in order, you need to just enter it like we did last time on the calculator, and hit sort and get it in order. All of these things have to be written in order. So stem and leaf plot, all those numbers need to be in order. So sort your data and then work off of that. But for ease sake, I'm just going to have us, I'm just writing it in order already. Okay, so dot plot is basically a number line, and then you're just going to put a dot above each value. Actually, let me change this last number to 42. And let me change both of these to 25s. Sorry about that. I just want to show you what happens if you've got repeats. Okay, so here's my number line. I'm going to start on the left with my lowest value and then increase up to my highest value. Now, like the histogram, you get to choose what you count by. Are you going to count by 2s, 5s, 10s? And it depends on how big of a spread you have. So I'm going from 10 to 40. So, you know, maybe 10s, maybe 5s. Definitely don't want to count by 20s. That's too big of a scale. Definitely also don't want to count by 1s. So kind of use something that feels reasonable as your grid. I'm going to just go 5s. So 10, 15, 20, 25, 30, 35, 40, 45. That's kind of a reasonable graph there. And then what you're going to do is you're going to just take each data point, you're going to put a dot above where it should be. So a 10, I'm going to have a dot here. A 12, now this is an estimate. 12 is between 10 and 15. It's a little bit closer to the left, so it's like right there. Here's 15, here's 17, 20 is here. Now 25 is here. I have 1, 2, 3, 25. So what you do when you have multiple data points is you stack them like this. Okay, and then 36 is right here, 37, 40, 41, and then 42 again stacks. So you can kind of see what happens if you get if your scale is too big, all your numbers get jammed together. So spread it out enough so that you can handle what numbers you're given. And that's how you do a dot plot. Pretty simple. The next type of graph we're going to look at is a pie chart. A pie chart is best used for qualitative data, so data that is not in number form. It can also be used in number form, but a lot of times those graphs you see are used for qualitative data. So for example, if I ask people what they had for lunch, okay, so let's say I took a survey and I had 8 people have a hamburger, and then I had 10 people have a salad, and I had 2 people have a sandwich. Okay. The way that a pie chart works is we operate off of probability. So we're doing that relative frequency that we did in the frequency distribution. And so the way you find the frequency is first you need to find the total, how many people were surveyed. So we're going to add that up, and we've got 20 total people surveyed. And then you're going to find the probability that somebody had a hamburger. So the way we do that is we say how many hamburgers were had over the total. So the probability of a hamburger is going to be 8 out of 20. Okay. And if we divide that out, we get 0.4 or 40% of the people got a hamburger. Then we go and we do 10 over 20. If I divide that out, I've got 0.50. And then I go 2 out of 20 and I divide that out and I get 0.1. Now, these percentages should all add up to 1. So that's a quick check. 40, 50, 10, that's 1, that's 100%. Okay, that's your check that you did that math right. And I picked some simple numbers to deal with, but it doesn't matter if you're getting 0.42 or 0.57. This is going to be an estimate of a graph. If we wanted to do it for real, we would get our protractor, measure degrees and all that stuff. But for our purposes, we're just kind of estimating. So let's look at a circle and talk about how we break this up. Here's a couple things for frame of reference that will help. Here is a quarter of the circle, and a quarter is 25%. If you don't know that, you should just throw that in your brain. That'll be helpful. If I add another quarter, so I take this whole, that's a half of it, and that's 50%. And if I take 3/4 of it, this totals up to 75%. So I'm kind of using those markers as estimates. So I'm looking at this, I'm saying, okay, let's see, the hamburgers are 40%. That's more than a quarter, but a little less than a half. So like maybe it's here, that kind of area. Okay. And again, it's an estimate, but we're kind of just getting close to it. So let's draw this graph out. Using what I know about 20, 50, and 75%, I'm going to go 40% is like right here. And let's say it's about right there, a little bit less than half. Okay. So this is going to be hamburgers. Salad is 50%. So from one of my lengths, either from here or here, I'm just going to extend out a full half. Okay. So I'm going to go like this. This is going to be salads. So that's a complete half circle. And then what I'm left with should look about right, 10%. I mean, I don't know, maybe it's a little bit big, but it's close enough. Okay. The point is that the sandwich wedge is smaller considerably than the hamburger. Okay. And it's a visual representation of what people had for lunch. And it's really easy to look at it and say, oh, most people are eating salads and hamburgers. Okay. That's just a quick way to see that. So you'll be reading some of those charts. Yeah, the last thing I want to talk about is how these graphs can be misleading. And that's something that's pretty important as you guys are taking your science classes, looking at articles online, looking at research as you're just living your daily life. Graphs and charts come at us all the time. And it's important to be able to tell what's happening on those graphs. So for example, I could make a histogram. Let's do this. And I could say, whoops. So maybe I'm measuring how many freshmen, sophomores, juniors, and seniors participated in the last school activity, okay? And so I'm going to say, well, there were this many freshmen, okay? There were this many sophomores, there were this many juniors, and this many seniors. Okay, now you could look at that graph and you say, wow, the sophomores really didn't participate at all. Okay, and this is an example of a misleading graph. First of all, there's no labels on here. We don't know what's happening. Now, what if I do this? This is 300. This is 301. This is 302, 303, 304, 305. Okay, now with that label, those labels, now tell me, here's my freshman, sophomore, junior, senior. Initially, we look at this and we say, hey, the sophomores really didn't participate in the activity. But what's the reality? Actually, the sophomores only had 5 less people than the juniors, right? So the sophomores had 300 people participate and the juniors had 305. Now, with that information, would you say that the sophomores really didn't participate in the program? I would say no, they totally participated. In fact, all of them were pretty even in their participation. And so it's because I'm not doing this break in the graph, I'm not letting you know that I'm actually just zooming into the very top of the bar chart and not showing you the whole bar. Now, if I started this graph at 0 and actually counted up to scale, the graphs would look almost even, and that would be a more accurate representation. Because I just graphed from 300 up, it really looks like the sophomores didn't participate. So this is how people can use statistics to mislead. If you're not paying attention to the labels or how the graph is drawn, you can be led to think one thing when that's actually not true. Another thing that I see often in reports and stuff is, instead of a pie chart looking like this and being graphed so you're like looking straight at it, it'll be kind of 3D. Excuse my drawing, okay? But kind of draw it like this 3-dimensional pie chart like this. And the problem is that when you draw something in 3 dimensions, the way that our visual looks is that it gets narrower at the back. So in order for this to look like it has depth, I actually have to create the illusion that this front wedge is bigger than the back wedge, when in actuality, they might be the same amount, but because I'm drawing it into the page with perspective, that V is going to look smaller than this. So if you're not looking at the labels and you see, hey, this is 33% and this is 36%, if you're not looking at that, that wedge in back can look a lot smaller when in actuality it's very similar or the same. So there's a lot of things like that in how graphs are drawn that can be misleading, and it's part of the goal of this course is to help you read articles and understand what's going on around you in a more informed way. So thank you for tuning in, and I will see you next time.